So welcome students. In this video, let us look at some important inequalities regarding trigonometric functions. So you have some inequalities which you need to understand. So in any acute angle triangle ABC, that is if A plus B plus C is equal to 180 degrees and all the three angles are acute angles, then tan A plus tan B plus tan C will always be greater than or equal to 3 root 3. And secant A plus secant B plus secant C will always be greater than or equal to 6. So these two relations are valid in acute angle triangles. And in any triangle, whatever the nature of triangle may be, cos A plus cos B plus cos C will always be less than or equal to 3 by 2. That means if the sum of three angles is 180 degrees, the sum of their causes will always be less than or equal to 3 by 2. And sin A by 2 into sin B by 2 into sin C by 2 will always be less than or equal to 1 by 8. Cosecant A by 2 plus cosecant B by 2 plus cosecant C by 2 will always be greater than or equal to 6. There are a lot of other inequalities also which are there in trigonometry, but these are the inequalities which you need to keep in mind before doing the problems. So in an acute angle triangle, the sum of tans is greater than or equal to 3 root 3. The sum of secants is greater than or equal to 6. In any triangle, sum of causes is less than or equal to 3 by 2. Product of sines of half the angles is less than or equal to 1 by 8. Cosecant A by 2 plus cosecant B by 2 plus cosecant C by 2 is greater than or equal to 6. So let us see why these are happening. So let us look at the first inequality. So in an acute angle triangle, tan A plus tan B plus tan C is greater than or equal to 3 root 3. So how do I prove this? So I am going to use some results which I have already derived. The first result is that in a triangle ABC, that is if A plus B plus C is equal to 180 degrees, tan A plus tan B plus tan C is equal to tan A into tan B into tan C. I have derived this in the topic of conditional inequalities of type 3. This is one result which I am going to use in this derivation. And next derivation regarding the concept of arithmetic mean and geometric mean. So if you have three positive quantities, the arithmetic mean will always be greater than or equal to geometric mean. So if you have an acute angle triangle ABC, that means all the triangle angles are acute angles. So tan A, tan B, tan C all are positive numbers. So tan A plus tan B plus tan C by 3 will always be greater than cube root of tan A into tan B into tan C. Now once you have this result, this implies if you cube this on both sides, tan A plus tan B plus tan C whole cube is greater than or equal to, if 3 goes onto that side, 3 cube is 27 times this power 1 by 3 and this whole cube gets cancelled. So you get tan A, tan B, tan C. So now from the result in the conditional identities, tan A plus tan B plus tan C is exactly same as this. So tan A, tan B, tan C can be written as tan A plus tan B plus tan C. So one of this will get cancelled out. This implies tan A plus tan B plus tan C whole square is greater than or equal to 27. So if you take square root on both sides, tan A plus tan B plus tan C is always greater than or equal to root 27, which is 3 root 3. So tan A plus tan B plus tan C is always greater than or equal to 3 root 3. And remember, this is valid only in acute angle triangles. So I have not proved this for obtuse angle triangles because AM will be greater than or equal to GM only if all the quantities that are considered are positive. So the next inequality that I am going to derive is that in a triangle ABC, cos A plus cos B plus cos C is always less than or equal to 3 by 2. Now how do we derive this? So in a triangle ABC, that means A plus B plus C is equal to 180 degrees. Now let us try to analyze the value of cos A plus cos B plus cos C. So cos A plus cos B plus cos C. Let it be equal to x. So this implies, now let us use the transformation formula for cos A plus cos B. So 2 cos A plus B by 2 into cos of A minus B by 2 plus cos C can be written as 1 minus 2 sine square C by 2 is equal to x. This implies, so what is cos A plus B by 2? A plus B is equal to 180 minus C. So A plus B by 2 is nothing but 90 minus C by 2. So 2 cos 90 degrees minus C by 2 into cos A minus B plus 1 minus 2 sine square C by 2 is equal to x. So cos 90 minus C by 2 is sine C by 2. This implies 2 sine C by 2 cos A minus B plus 1 minus 2 sine square C by 2 is equal to x. So now I'll try to convert this into a quadratic in sine C by 2. This implies, if I send everything onto that side, you get 2 sine square C by 2 minus 2 cos A minus B times sine C by 2 plus x minus 1 is equal to 0. So this is a quadratic in sine C by 2. So now what is sine C by 2? Sine C by 2 by quadratic formula is minus b plus or minus root of b square minus 4ac by 2a. So sine C by 2 is equal to minus b 2 cos A minus b plus or minus root of b square, the square of this, that is 4 cos square A minus b by 2, b square minus 4ac minus 4 times 2 times x minus 1 by 2a is 4. So the value of sine C by 2 is this. So obviously for sine C by 2 to be defined, this discriminant has to be positive. So this implies 4 times cos square A minus b by 2 minus 2 times x minus 1 has to be greater than or equal to 0. So this 4 gets cancelled. This implies 2 times x minus 1 is less than or equal to cos square of A minus b by 2. So this implies x is less than or equal to 1 plus half times cos square of A minus b by 2. So now if you observe this in equation, so depending on A and B, so whatever you select for A and B, so x will always be less than 1 plus half times cos square of A minus b by 2. So now we know that the maximum value of cos square A minus b by 2 is 1. So x will always be less than whatever may be the value of A and B. Whatever may be the value of A and B, cos square A minus b by 2 will always be less than 1. So x will always be less than 1 plus half into 1, which is 3 by 2. That means irrespective of what the angles are, cos A plus cos B plus cos C will always be less than or equal to 3 by 2. So that's how we prove this inequality. So the next identity that we're going to see is that in a triangle ABC, sine A by 2 into sine B by 2 into sine C by 2 is less than or equal to 1 by 8. So this is also very straightforward if we have already proved this. So because we have seen in the topic of conditional identities that in a triangle ABC, cos A plus cos B plus cos C will be equal to 1 plus 4 sine A by 2 sine B by 2 sine C by 2. So this is a very standard conditional identity for a triangle ABC. Now we have seen that cos A plus cos B plus cos C is less than or equal to 3 by 2. Hence this is less than or equal to 3 by 2. So this implies if you send this one onto that side, 4 sine A by 2 sine B by 2 sine C by 2 is less than or equal to 3 by 2 minus 1 is half. This implies sine A by 2 sine B by 2 sine C by 2 less than or equal to 1 by 8. Hence we can prove this third inequality. So the next identity that we're going to prove is that in an acute triangle ABC, secant A plus secant B plus secant C is greater than or equal to 6. So to prove this inequality, let us use the concept of AIM greater than or equal to HM. Arithmetic mean is greater than or equal to HM. So let us take secant A, secant B and secant C are the three quantities. Because the triangle is acute, all the angles are inside 90 degrees, hence all these ratios are positive. Hence we can use this statement. So arithmetic mean of secant A, secant B, secant C is secant A plus secant B plus secant C by 3 is always greater than or equal to, what's the formula for harmonic mean of these three numbers? 3 divided by 1 by secant A, which is cos A, plus 1 by secant B, which is cos B, plus 1 by secant C is cos C. And this implies secant A plus secant B plus secant C is always greater than or equal to 3 by cos A plus cos B plus cos C. So now we have already seen this. So we have already seen that cos A plus cos B plus cos C will always be less than or equal to 3 by 2. So we have already derived the condition that cos A plus cos B plus cos C will always be less than or equal to 3 by 2. The maximum value of this is 3 by 2. So secant A plus secant B plus secant C is always greater than 3 by whatever is the value of this. And to get the minimum value of secant A plus secant B plus secant C, we substitute the maximum value of cos A plus cos B plus cos C in the denominator. So this is always greater than or equal to 3 divided by cos A, sorry, this is 3 into 3, right? So 3 into 3 divided by cos A plus cos B plus cos C is less than or equal to 3 by 2. So if you substitute the maximum value, you get the minimum value here. So you have by 3 by 2, 3 and 3 gets cancelled. So it's always greater than or equal to 6. So secant A plus secant B plus secant C will always be greater than or equal to 6. So for different values of A and B and C, it might be more than 6, because cos A plus cos B plus cos C can be less than 3 by 2 also. If this number is less than 3 by 2, secant A will plus secant B plus secant C will be greater than some number which is greater than 6. That means its value is higher, but its value can never be less than 6. So the least value of secant A plus secant B plus secant C is 6 in a acute angled triangle. So the last identity that we're going to see is in any triangle, cosecant A by 2 plus cosecant B by 2 plus cosecant C by 2 is greater than or equal to 6. So again, we'll use the concept of arithmetic mean greater than or equal to geometric mean for positive quantities. So now let us take cosecant A by 2, cosecant B by 2, cosecant C by 2 as three quantities. So A, B, C are angles of a triangle. So obviously A by 2, B by 2, C by 2 are all acute. Even if A is obtuse, once you go to A by 2, it will become acute. So these three are positive quantities. So cosecant A by 2 plus cosecant B by 2 plus cosecant C by 2 by 3 is always greater than or equal to cube root of cosecant A by 2 cosecant B by 2 cosecant C by 2. So now if I send this 3 onto that side, so cosecant A by 2 plus cosecant B by 2 plus cosecant C by 2 is always greater than or equal to 3 by cube root of sin A by 2 sin B by 2 sin C by 2. So the sum of this will always be greater than 3 by this. Now we have already seen that sin A by 2 into sin B by 2 into sin C by 2 will always be less than or equal to 1 by 8, right? That is, the maximum value of this is 1 by 8. So if you want to get the least value of cosecant A by 2 plus cosecant B by 2 plus cosecant C by 2, so let us substitute the maximum value for the denominator. So you get the minimum value for the fraction. So is greater than or equal to 3 by cube root of 1 by 8. is nothing but 1 by 2. So it's greater than or equal to 6. That means cosecant a by 2 plus cosecant b by 2 plus cosecant c by 2 will always be greater than or equal to 6. Thank you.